So 8051 port 1, 2 and 3.
Okay.
All these ports have internal pull-up resistors. We have internal pull-up resistors.
Okay.
So for example, this is a port with internal and so on, and every pin will be connected to a resistor. Like this.
Okay.
And all the other ends will be connected to VCC.
Yes.
So by default, every pin is connected to VCC through a resistor.
Yes.
Okay. So this VCC, from this VCC, voltage will pass to every pin. So by default, all the pins have 5 volts. Default voltage of all the pins is 5 volts, except port 0. Because for port 0 there is no internal pull-up resistor. Maybe the reason why they didn't have a pull-up resistor inside port 0 is previously port 0 was used for analog and data lines.
Yes.
So if by default if there is any value on this, the other device may consider it as a data or address, whatever it is. So that's why they left it idle. Okay, they left it idle. And for that reason, we have to connect a pull-up resistor externally.
Okay. I know.
So the default voltage is 5 volts on each and every pin.
Okay.
So whenever you design anything, whenever you connect a sensor or device, you should keep it in mind that default voltage will be 5. If you want to connect a sensor, if you want to connect an LED, you should keep it in mind that by default it will be 5 volts, so LED will be on or off.
Yes.
Okay. So now let us start with LED. This is and ground. If you connect like this is LED is diode. It's just a diode, but because of its construction or its structure and everything, it emits light. Okay, it's just like a normal diode. It allows voltage from positive to negative. Okay. Whereas, unlike the other diodes, if you give it in reverse direction, the LED will blow up. It will be damaged. So you should make sure that LED is connected anode to positive and cathode to negative.
I know that cathode means.
Anode means positive. Positive terminal is called as anode.
Okay.
Negative terminal is called as cathode.
Okay.
Okay. Anode should be connected to VCC and cathode to ground. But if you connect like this directly, what happens is, as I already told you, this is just a diode. It allows voltage to flow through it if it is in forward biased condition. So all the voltage, all the current will just flow through this and will be grounded. So there is a chance of using more power than it is necessary. Okay, and LED will glow with full intensity, very bright, and then within a very short period of time it will be damaged. So you have to limit current in order to save power as well as in order to save the LED. So to limit that, we use a resistor. In general, we use 330 ohms. You can use 1K, 10K, any value, but the difference will be intensity. If you use 330K, it will glow with more intensity, bright. If you use 1K, the intensity will reduce. If you use 10K, intensity will reduce a lot. If you use more than that, it will not glow, because very less current will pass through that. It doesn't matter if you connect resistor here or here. You can connect it near cathode or anode. It's up to you. It doesn't make any difference.
We can connect it in the other way, right? No.
Which one?
Oh.
This one? No, it's not possible.
Not possible.
Anode should always be connected to VCC and cathode to ground. Whereas resistor you can connect near cathode or anode. Doesn't make any difference. Both are same. Because if you connect here, electrons will be, they will be limited here. If you connect here, they will be limited here. Anyhow, they are not passing through this. You are just blocking the passage. That's it. Maybe before LED or after LED. And there are two ways to connect this LED to microcontroller. Common anode connection and common cathode connection. Common anode means this will be connected to VCC directly. Anode will be connected to VCC and cathode will be connected to microcontroller pin.
Okay.
So VCC is given to anode and cathode is connected to microcontroller pin. So which signal should be given to in order to light this LED?
0.
0. Yes. If you use 0, LED will be on. If you give 1,
Off.
off. This is common anode connection. Common anode connection. And there is another one called common cathode. Cathode is directly connected to ground and anode is connected to microcontroller. If it is 0, it is already connected to ground here and again you give 0 from here, it will not glow. LED will be off. If you give 1, LED will be on. So like this you can connect it either ways, either common anode or common cathode.
Okay. Okay.
Now I am writing a program to toggle LEDs connected to port 0. It's a basic program.
Okay.
Hash include respect for address is a library file for 8051 or 52 microcontroller. SFR LED equals to 0. SFR is a keyword. It's a keyword. Keyword for declaring a variable name for any of the registers. There are special function registers in 8051 for timer, for serial communication, for each and every port. There will be a specific name. That's a name allotted for that particular register.
How many SFR do we have?
I don't remember exactly how many are there, but we will come across each and every register that we use in programming.
Okay.
I can't tell you the number. So if you want to name them, if you want to give a separate name, because by default the name for port 0 will be port 0. Okay. If you want to give it another name that you can remember, another variable, then you should use SFR. Okay, just like we use int, float
Okay.
for different types of variables.
Okay.
We use this for especially for registers. LED is equal to 0x80 and 0x80 is the address of port 0. Okay, this is the address of port 0. For four ports, there are 4 addresses. Respective 80, 90, A0, B0 for port 0, port 1, port 2 and port 3 respectively. 0x80, 0x90, 0x A0, 0x B0. So if you want to name port 0, you should allot this address to that name. Okay, whenever you mention LED, then compiler will consider it as port 0. Okay, and in main program I am writing a continuous while loop because I want these LEDs to toggle continuously. LED is equals to 0x AA and LED is equals to 0x 55. And AA declaration format is 1010 1010 and 55 is 0101 0101. Okay, let us assume that all these LEDs are connected in common cathode connection.
Okay.
Like cathodes are all grounded and anodes are connected to port pins. So they will be on if you give 5. They will be off if you give 0 volts. So here consider this as P0.0 and this is P0.7. Okay?
Yes.
So first one off, second one on, third one off, fourth one on. So all the odd number of LEDs are off and even numbers are on. Okay? And then immediately we are writing 55. So those who are those LEDs which are in on condition will be off now, and those which were in off condition will be on now. Okay? So this is how we can toggle LEDs. But there is a problem with this. If you write instructions in this way, you cannot observe any change. You write and test it on hardware. You will not observe any change because here LEDs will be on, and immediately we are turning off those LEDs which were in on condition and turning on which were in off condition. Okay, and the time taken for this is almost in less than or equal to 1 microsecond. 1 microsecond means there will be 10 lakh microseconds in 1 second. With a bare eye, human eye, we can observe a change which takes more than 40 or 50 microseconds. We can observe, we can just observe that. Okay, we cannot grasp that. We can just observe that there is a change if it happens, if it takes more than 50 microseconds. If it takes less than that, no, it is not possible. Sorry, 50 milliseconds, not micro.
Okay.
Milliseconds. Because again, 1 milli equals to 1000 micro. We can't even see that. Okay, so it seems to be all the LEDs are on state. You cannot see any change. So in order to see the change, you should turn on few LEDs and then give some time for them, and then change the state, and then give some time again. For that, we write a sub-function here. I hope you know what is a sub-function, how to write and how to call it. I'm writing it as delay. For I equal to 0, I less than if you write like this, and again, you should declare prototype declaration here. Declare.
No problem before SFR.
No problem. You can declare anywhere. See, this is This is where you include library files, and then this is a declaration part. In this you can declare anything. Like you can declare variables, global variables, you can declare function prototypes, you can declare special variables like this, SFR. So, once the odd number of LEDs are off and on number of LEDs, even number of LEDs are on, then you call it delay function. You go here and execute this function. There is a loop inside a loop. So for every one digit incremented in I, j will be incremented for 1000. So totally this will take 1000 into 1000, like 10 lakh machine cycles. Okay, more than a second, slightly more than a second, and then you come back, and now alternate LEDs are turned on, and then again it takes some time. Now you can observe the difference.
So this one you are connecting
port 0.
No, not port 0. 8 LEDs.
Yes,
That one.
not one.
And you are alternatively on this. If I want to make only one, I can make 0001 or 0000.
No, I'll write that now also.
1 second, just 1 second. Before, after, okay. Delay.
If you want to use only one LED and that is connected to P0.0, then you should use S bit. Bit means single.
Single.
It's just a single bit. A pin is considered as a bit. Okay, it can carry either 1 or 0, a single bit of data. So S bit LED, again LED is just a name. You can use anything.
Yes,
You can
yes.
write S bit Ali is equal to P0.0, it's not a problem.
Okay.
P0, this caret symbol should be used. As we are writing in key compiler, use this symbol. P0.0. Now here, instead of giving 8-bit data, it should give single bit.
Okay. If I want to use 2, can I make a split LED B0, this one 0, then B0, P0, this, what's this?
So call it 0.0.
Okay, 0.0, then 0.1.
You should mention, then you should write, you should use two variable names, LED1 and LED2.
Yes.
And you should write two instructions here. LED1 equal to 0
Yeah.
and LED2 equal to 0.
Yeah.
Instead of writing two instructions, if the other pins are not used in port 0, you can directly name it LED and just give a 8-bit data. Like 8-bit data means like this 0000, 0011. Go on.
Yeah, I understand. But now I cannot make use of
Yes.
the remaining bits.
That's it. Even if you want to make use of the remaining bits, there is another way.
No.
That's called OR operation, logical OR.
Okay. How?
See, if you write like this, P0 is equal to 0xa. All the data will be, all the bits will be changed. If you write like this, see, if you want to turn on only first two LEDs, you don't want to disturb these LEDs, these pins. Then instead of writing, this is 0x03, right? 1 1.
Yes.
3.
Okay.
Instead of writing P0 LED is equal to 0x03, should write like this: LED or logical OR. You will find it here in the keyboard. Here, yes. Equal to 0x03. Then what happens is, whatever the data may be in port 0, like there will be some XX, XXXX. This X will remain same, and then these two will become 1.
I can use those later?
Yes.
Okay, if I want to use the 8th one, what shall I write?
Only 8?
No, now I use the first two.
See, if whatever you write, if you want to change only 8th bit, okay? We will come to this later. No?
Okay.
While doing programming, you will understand.
Okay.
Just keep it in mind.
Just a second. Okay. Finish.
Okay? Clear?
Okay.
So this is about output pins. Now we'll see how to take inputs, like using a switch. We use a 4-pin switch generally.